Today we're going to revisit the whole idea of inverses. And remember, in matrices, we do not have division, so we need to do the undo, which is inverse of A. So if you will stop the video and get your calculator out, we're going to put this matrix into the A matrix, and then I'm going to remind you where to get the A inverse key. So getting the matrix into A, remember to go over to Edit. We're going to put in a 2 by 2. We're careful when we put in our values. And when we quit out of here, we'll do a matrix A, and then the inverse key is just the x to the -1 button. And when we do that inverse, it'll look a little strange. There'll be decimals, but remember to change decimals to fractions. We just use the fraction button and record the inverse as, and again, be careful to record. This should be a 2 by 2. So we'll have our -5/16, 9/16 in the first column, 1/16, and a -5/16 in the second. So to find the inverse, we'll use the calculator. Please press pause again and put the 3 by 3 in for number 2, and then check your answer. So again, you've walked through, you've put this into your A matrix. The inverse of A should have been, and again, these numbers will sometimes be large. If you don't see them, just move the arrow key over to get the next entries. And in a minute, we'll see why we use these when we're solving for matrix equations. And I'm just hitting the right and left arrow buttons so that I can get them. And one thing that I want to show you before we go on, final answer for number 2 is recorded. What I'd like you to do is I want you to see what happens when I punch out A times the inverse of A. So in regular day math, we just get ones, but in matrix, the undo button, or to divide, is what we call a identity matrix, and it's kind of a special matrix. And that identity matrix, if you notice, you'll have the main diagonal are 1s and everything else are 0s. So looking at exercise number 3, you can kind of see it. It's an equation, and if we want to solve for x, what we have to do is we have to get rid of this matrix. So I'll call this matrix A and matrix B, and we want to solve for matrix X. So if this were a regular equation, like a 4x equal 12, we would divide both sides by 4. However, in matrices, we don't have division. So what we're going to need to do is to multiply both sides by A inverse. So copy down this statement. This is what you're going to do as far as undoing. So A times A inverse will just be a 1, and then we'll solve for x, and then actually we can type this into the calculator as long as we have A and B into our calculator. So again, we'll go to our calculator. Let's put in the A matrix, how I have it labeled. So A matrix is a 2 by 2. You'll put your entries in. You'll actually put in a B matrix. and the math involved to get the matrices, again, we want to solve for x. So what we're going to do is multiply both sides by A inverse. So x will equal A inverse times B. So the matrices that if I multiply A by that matrix, X's matrices, the solution for X will be a 2 by 2 matrix. Hit pause and work through number 4. When you have an answer, click play again and see if you've got the correct answer. Notice in number 4, we have an A matrix, we have a B matrix, so I chose to put this in a C matrix when I put it in the calculator. So to solve for B, we're going to multiply both sides by A inverse. You have to multiply A inverse first when you multiply it by another matrix. And if you type in your calculator, A inverse, and again, why did I put C? Because we were finding a different matrix. The answer will be a -5, -2. As you're going through, stop, rewind. Now this last equation actually has 2 steps. So before I go through the matrices, let's just imagine I had a regular equation and I want to remember the algebra and what I have to do first. So if I had this regular algebra problem, I would subtract 1, 5x equals 11, divide both sides by 5, and I'd be good to go. So you should see this equation of a matrix. Before we're going to get rid of the matrix in front of x, I'm going to have to move this matrix on the other side. And just like algebra, when I move something from one side of the equation to the other side of the equation, I should do the opposite. So this first step, it might look a little different, but before I can take this A inverse like I just did, I'm going to have to subtract these 2 matrices. And remember our rules for subtracting. They must be the same dimension, and then I just subtract off the corresponding pieces. So -19 minus 1 will be a -20, and 18 minus 5 will be a 13. Now this should look just like options 1, 2, 3, and 4. So what will I do? I want to solve for x. So I'll put this A into the calculator. I'll put B into the calculator. To solve for x, I'm going to multiply both sides by A inverse. Again, mathematically, why does that work? Because A inverse times A is 1x, and that's what we're trying to solve for. So I'm going to put pause for a moment while I punch this into my calculator. You may too, and then see if you come up with the right answer. So what I've done is I've put this matrix in A, this matrix in B. To solve for x, we're going to go A inverse B, and our final answer should be a 1 and a -3. So I have a worksheet that I'd like you to use. Please use your notes as you're going through that and ask questions as you can.